All right, we're good? All right, cool. Welcome, everybody. I see some new faces. For those of you who have not been to one of our events before, welcome to Santa Barbara JavaScript. We're the best meetup in town, hands down. A couple of little housekeeping things before we get started. First, I want to thank our sponsors, starting with WorkZones. WorkZones has shared workspaces as well as private meeting rooms. If you're interested in checking it out, we can get you connected with a free pass to try out the service. And if you like it, the rest is in your hands. Next sponsor of ours is Invoca. My co-organizer, Garvin, works there. Invoca hosts us a couple times a year at least. We were there last month. PayJunction, another sponsor of ours. And lastly, we've got a partner relationship with O'Reilly Media. And we get discounts on books and videos and conference passes. And if we use the conference discount 3 times, I get a free conference pass. We'll raffle it off here, something like that. Meetup did ask organizers of US-based meetups to make a quick public service announcement, and I believe in this strongly, so I'm going to go ahead and take their suggestion, and that is midterm elections are coming up. So regardless of where you stand on the political spectrum, this is not intended to sway anybody with their political persuasion. Midterm elections are important. It's a chance to participate in the electoral process, to have your voice heard, and to try and choose representatives that best represent your interests. So please register to vote and vote in the upcoming elections. With that, upcoming events for Santa Barbara JavaScript. Next month, we will be at my employer, Procore, for Lightning Talks, our annual event. This is our 4th annual Lightning Talks. There are still spots open to speak. If you have not spoken at an event like this and want to dip your toes in the water, it's just 5 minutes. That's all you need is 5 minutes of material. It's a great way to get a gentle introduction to it. There are still spots available to speak. If you want to speak at this event, see me or Garvin or RSVP on the meetup and tell us you want to speak. In November, at a yet to be determined location, my colleague George Barrios will be speaking, topic TBD also. And in December, we normally meet the first Monday of every month, but that's my birthday, so I'm going to push it back a week. and I'm going to speak about if you're interested in speaking either at Lightning Talks or doing a full-length talk at any of our upcoming events. See me, see Garvin, hit us up on Meetup. We'd love to have you. Any topic related to JavaScript is fair game. And with that, I'll turn it over to tonight's speaker, my colleague, Mr. Dallas Hall.
Thanks, Tim. All right. So like Tim said, any topic related to JavaScript, no matter how crazy, far-fetched, or wrong it seems, he'll let us present on, which is how we get to Redux on Backend. You might be wondering how we came to this. Well, honestly, the reason I came to even think about Redux on the back end is I like games. I really like them, like a lot. But I like games that are multiplayer. And if you want a multiplayer game in the modern age, you pretty much need some kind of server at the very least to relay messages back and forth. And get your clients to talk to each other and hopefully show the same thing on your screen as your friend is seeing on their screen, so that somebody's not shooting and then you're dying, but it happens in the wrong order. Which got me looking into game servers. And the thing about game servers is there are a lot of fully baked options out there. You can go with some Unity or Unreal themed engines, and you can get a lot of cool things going for your backend. You can use a lot of cool prescribed patterns. And it's a lot to wrap your head around. So if you're a front-end developer like me, and you're well, I want to make this game, and I don't want anything really to happen except for these guys to be able to move around and maybe bump into each other, that seems like a lot of overkill. And also, a lot of the services are paid. And I'm well, I really don't want to do anything more than maybe pay my $5 a month DigitalOcean subscription, or maybe burn my free year of Amazon Web Services to get this thing up and running to play it with. So I got thinking, what if I build my own? Which is really fun, because I like to program. So now I love games, I like to program. I started thinking, what would my dream game server have? Well, the first thing that it needs to do is it needs to show the same thing to everybody. So I need a single source of truth. Oh, this is seeming familiar for people who know a little bit about Redux. I want to send minimal amounts of data. Like I said, I don't want to spend more than $5 on my server, and ideally less than that if I can swing it. So minimal amounts of data. I want to send the bare minimum, and I want to have a lot of people connect just for the fun of it, because I enjoy that. Also, this is made to go on my phone, so that's my constraint, is I don't want to burn my mobile data. And then replay. Like, I think it's really cool when games have the ability to like go back in time for the course of a game and like play it from the beginning to the end, exactly how it happened in the past. Well, that's pretty cool. And maybe I'm not building this right now, but I'd like to have the option to do it later and not really lock myself out of that. All right, so knowing that that's my dream game server on a very high level, let's take a look at what Redux has. So Redux has got 3 principles if you go to their documentation. And guess what the first one is? Single source of truth. Redux is really just a bunch of functions that spit out this object, and that object is your source of truth. It's a little bit more complicated than that. We might get into that a little bit, but it's one way to say there's one source of truth. It's not you listening to one part, somebody else listening to another part. The next principle of Redux is a read-only store. And what this means is, like, by principle, they want you to only update the state of your application the way they prescribe, which is primarily through sending actions. And an action is basically this instruction saying, here's what happened, or what should happen, depending on how you phrase them. So you're trying to send like the minimal amount of data. You're not sending the state of the app over the wire. You're sending how to change the app over the wire. And lastly, they prescribe that you change the state through pure functions. Now, the really nice thing about a pure function is that you have repeatable results. If you have the same input over and over and over and over again, you're going to get the same results, or predictable results. Well, guess what? All 3 of these things really jived with what my dream game server had, and it used something that I'm fairly familiar with working on front-end technologies, specifically with React and Redux. So with that, with our requirements met for our dream game server, I was like, well, let's build it. So here's the simple version. So here's what we want. We want a front end with React and Redux. React because I'm fairly familiar with it. I don't have to do a lot of work to get things updated. If you haven't played with it, it's really fun. It's easy to get started with the Create React app. Redux itself is also really simple to get started with. You go onto the Redux website, and there's a little getting started page. Or one of the better ways to go is to log on to one of the free Egghead IO videos that Dan Abramoff has made. And there is a write your own version of Redux example in there that'll kind of get you like unafraid of what this thing really is. How about the back end? Well, I want to keep it as simple as I possibly can. So for the simple version, I just want a Node.js server, maybe Express, and Redux. All right, you guys are looking at me like, that's it. And that's the end of my talk. I'm just kidding. How would this thing work, really? How am I going to really have things happening here? Well, I beefed up the Node.js server, and I added Express in front of it so I could connect a few different things. And I decided I'm not going to have this thing be optimistic. If you're familiar with optimistic UI on the front end, it means that before the server is confirmed that a thing has happened, you show that to the client anyway, and that gives her a really nice user experience. I said I'd rather be honest to the client and let them see only what actually happened, mostly for the sake of simplicity. So what I'm going to have happen is I'm going to have the front end send an action. Forgot. In this app, I need to handle 2 different cases. Sorry, I have to go here because that's the order I wrote the actions in, and my fades are out of order. In this app, when a user first visits this page, they haven't been there before. And if you have Redux on the back end and Redux on the front end, you might end up with 2 different states, right? Because your front end's never seen the back end before. So I'm working off the premise that the very first time a user visits this, we're going to hydrate their state. In this case, the only thing I'm sending is a list of the players and their locations. OK. And then if I need to update the player, our action might look something like this. So we have a type. Every action has a type and a payload. Our type is move player up. This is typically a string that just identifies to our reducers, which are just functions that says, hey, when we get this, I want to do one thing, do it well. And then we take in the payload, which is the player ID. So if you think about this, that's all it takes to move a player around on the page. I can create multiple different actions or an unlimited number of actions as long as I handle them case by case on the server. So in order of this happening, we get there and we want to, let's say we have a user on the page and we want to move them around. So what do? We say, hey, I'm going to send an action up to the server. Notice I didn't like update it. I didn't send it to my internal Redux first. I sent it straight to the server and I said, hey, here's my action. The server says, great. I'm going to go ahead and dispatch that. I'm going to run it through our reducer. I'm going to apply it to that function. It's going to change the state of the whole application. And after it's done that, I'm going to send it back down to the client where just the action, once again, I'm not sending the state of the app down to the client. I'm sending the action down to the client. It's going to run in the client reducer and then finally update the user interface. Now, some of you guys are thinking, well, isn't that going to feel a little laggy? I'll get to performance at the very end of this. The answer is yes and no, and it depends on your device. All right. What happens? So that's nice, but what happens when my DigitalOcean JavaScript app, my little Express server running says, hey, too many people have connected, and I'm out of memory, and I'm dead. Well, I've just lost all of our game states. So I decided, well, I want a way to persist this, and I want it to be also very simple. So there are like a dozen different adapters to plug socket.io, or sorry, just to plug in Node to Redux, and you can save whatever you want as long as it can be turned into a string. Well, guess what? Redux recommends that everything in your store be serializable. Well, that works out really well for me. Now I can store my entire state of my application in Redux. So here's what that looks like. Our front end, once again, still just React and Redux. The back end, we're going to have Node and our Express server and Redux, and then we're just going to add in a little bit of Redux. All right, and guess what? It doesn't change the action of things too much. We still send our action to the server. But this time, the server is going to say, hey, I'm going to go ahead and pull out the store and grab that out of Redux. Sorry, the state. I'm going to create a new store. I'm going to apply the action against the store. And then I'm going to broadcast that action out to my clients, and at the same time, persisting the state into Redux. Now, I know that was like a really kind of long. OK, if I hit the arrow button too many times, oh, there we go. I had that all on like one keyframe before, and I kept on skipping over it. And Keynote doesn't really like you to rewind step by step. Anyway, so I want to pause here and just first off ask if anybody has questions, because I know like not everybody has familiarity with Redux, and I glazed over a ton of what's actually happening. So now is your chance to like pause me mid-presentation while looking at this crazy diagram and say, what is really going on at any given point? Any questions? Yes?
How are you communicating between the browser and your Express app?
Oh man, how am I communicating between the browser and my Express app? So right now, my Express app has a socket.io server or socket.io plugin to the Express server running, and I'm using the the socket.io front-end library that they recommend using. So when my component first mounts on the page, I open up a single socket connection, and I broadcast, and I say, hey, I'm new. And my app says, hey, new guy, here's your hydrated state. Here's what your app should look like if you're a new person. Yep, so everything here is happening over a single socket connection. Any other questions? Yeah?
Did you say that every time an action is dispatched, a new store is created in this state in Redux?
Yes. Yes. So the question was, am I saying like every time an action is dispatched, a new store is actually created? Yes. And I'm not saving that inside of my JavaScript process. It's a reference to that store that I throw away. So basically, all I have to do is give the store a unique key to store it in under Redux. I can pull it out, create a new store based on that initial app state, apply the action against it, which will return a new state, and I just save that new state back into Redux, and I just let the garbage collection run on Node. Yeah. Yes?
Do you have worries with the two states not syncing up?
I'm glad you asked that. The question is, do I have worries about the two states not syncing up because of missed messages? So the nice part about the Socket.io library is that it gives you this little nice on disconnect function. So guess what? I decided I was going to really abuse that and say, if it disconnects and it has to reconnect, I'm going to treat that as if the user was brand new, and it gets whatever the latest full state is, and it just dumps it back down to the user. So if a user has a really terrible connection, they're going to have a fun time downloading the entire app state over and over again, but at least I know they have all the data. Now, there are way better ways to handle that. Like, for instance, we could give every message a unique number that progressively gets higher and higher and higher. And we could apply that on the server, and then you could say, hey, if I'm off by 1, I can just request the message that was missed. But that's getting like way into like some things that I made a really simple app, and that's beyond it. But yeah, totally available using Redux. Yes?
I'm assuming that these are two separate instances of Redux, right? You don't have one, so like one global instance of Redux that is managing both browser and Discord.
Yes, that's correct. So the statement was, we're assuming 2 totally separate instances of Redux, one on the front end, or one per client on the front end, and then one on the back end. And that's correct. I don't have like one super central Redux store managing everything. Yes. All right. Oh, yeah.
How do you choose what part of that global store gets sent to the client?
Oh, man. So the way I choose which part of the global store gets sent to the client is I only give the client exactly what they need. So for instance, the app I'm going to show you, I'm keeping track of a global map, but all a client needs to know is where users are, not necessarily the whole map. So all I send down is a list of users and their locations. I let the client handle any of the dirty work for collision detection, or maybe objects on the screen, anything like that. All right, so what about simple scaling? So the nice part is, let's say if you have an app that does like multiple things, you can share that same Redux instance, and you can have multiple Node.js backends doing things and doing different parts of your app. You're like, oh, wow, that's great. But that's really just like 2 separate apps. So let's take it a step further. This is just one step further. So side note, I have built this particular one, and it's super cool, minus this part. I just wanted to show you guys a laser show on the screen. So this is basically a way you could automatically scale your node instances. You could even, depending on how you set up your server, like if you decide to use a WebSocket server, specifically like Enchan or maybe a Rust-specific WebSocket server, you can actually just use these JavaScripts as pure functions, and you can use like AWS Lambdas or Azure Functions or what have you to scale this relatively infinitely. And with that, you can also scale up using a Redux cluster instead. And you can synchronize, if you are using your Node.js and Socket.io servers, you can synchronize those individual servers also using that Redux cluster. It does get perpetually slower if you do that. So, I mean, if you're really talking about hundreds of thousands of users at once, you probably want to go WebSocket server and functions over Socket.io servers. What's this guy doing here? We haven't talked about any kind of long-term storage, right? Very few companies are using Redis as a long-term storage. Normally it's used as like this caching layer. So normally we want something like a little bit more persistent, something maybe with a real hard drive, not just living in RAM somewhere on some server that's shared with some other person that could go down. So we want a Postgres instance or maybe a series of instances on Postgres. Well, Postgres is going to be notably slower than Redis as we scale up. So what we're going to do is we're going to say, we can't save to Postgres every time. OK, I'm getting ahead of myself because I forgot what my next slide says, which is, why would we do that? So why would we do this? In what world does it make sense to have all of these different instances of Redux, all of these instances of Redux, all going off of the same central store right here, central state stored in Redis? All right, we're going to take a break, and we're going to ask ourselves, what does Redux on the back end give us? And this will hopefully bring us to the answer of like why I would go through the pain of doing something like that. Okay, first off, it gives you an authoritative server. It's your single source of truth. And we've talked about that, and I've hammered it 3 times now. But that's really good for game engines and also real-time document editing. Anything where people need to see the same thing at the same time, this is a really great way to ensure that, because if you play the actions in the same order on the same state, you will always get the same results. This is probably one of the coolest parts, and this is more leaning towards our real-time document editing, but this gives you multi-user time traveling. Think of like an undo that's keeping track of every action that every user has done, but depending on how you structure your data, if you structure every action to be undoable, you could give yourself independent undo per user on a live document. Okay, and this one is my favorite. This is sending only the minimum information needed to change the state. This is probably like the best part about it, because oftentimes when we're dealing with a REST interface, we're sending like an entire object. We're not just sending a small instruction saying, do this, but it really makes you think about how you've structured your backend. Oftentimes we'll send the value to be stored in the database. And for my example app, that's exactly what I did, until later I realized I only need to send an instruction, and I can let Redux determine what the value should be that's stored. Oh yeah, this is my other favorite part, all to do with actions. We give ourselves a common language for updating the state of our app. Now that action that we generated on the front end is also used on the back end, and we're done. Right? And if we're dealing with a socket interface, we're not like continually spinning up new API endpoints. We're just sending this over, passing it into Redux, and saying, hey, go to town. You got it. Tell me what the state should be. This next part's really cool. Server persistent state. So we can gracefully handle refreshes and disconnects, all by just saying, hey, when they disconnect, let's just give them the brand new state of the app. This also fits a multi-client update paradigm, meaning if I need clients that need different bits of information from a Redux store, Redux also gives us some clever ways of doing that as well, and I want to touch on that a little bit later. Okay, so maybe it's not the worst idea. I'm going to give my caveat here. It's still a weird one and not totally fleshed out. So I don't expect you to like go back to your companies and be like, we should use this in production. This is the coolest thing. I saw this at a JavaScript meetup. I haven't even written a terrible Medium post about this yet. So wait for that first. And then, of course, when would I really use it? So I'm going to lay out an example here. So I want you to imagine we've got a legacy database. And this thing is old, and a lot of things rely on it. Along with that, it's difficult, if not impossible, to shard. And maybe we're reaching like the ends of our theoretical limit on what we can do with this database. Maybe it's hard to modify the table structure. Like the thought of running a migration on this database is like nightmares to your DevOps team. They're like, what? No, don't touch it. Maybe you have like super deeply connected data in there that also makes like any of these other things really difficult. You're at the hardware limit of connections to the database. And then your boss comes to you and says something like, hey, we build enterprise software here. I want it to be like Google Docs. Think of how many times like people are typing into Google Docs and that needs to be like updated and saved. Oh, and you've got that database and you're like, oh, please keep on running. If anything, we want to reduce connections to that thing. So we want to reduce those number of one-off requests. We can track the state in Redux, and that lets us turn, say, 100 user actions into one bulk update. Because what the database cares about is the state of the app. What Redux cares about is the individual action to get to that state. So we could theoretically, on a timer, just say, hey, every 5 seconds, I'm going to dump whatever the state is of this app back into the database. Now we've got our persistent storage, and we've got our live fast updating that users are expecting when they want a real-time web service. The nice part is, like, there's no need to replay those 100 actions on the database. It only needs the one bulk update. We just dump the store, and then now this is assuming a normalized state shape. So assuming a state in your Redux store that matches the tables in your database. Now, if you have that, updating your values there is going to be almost like incredibly simple. You're going to send this giant JSON payload, And whatever your backend is going to look at that and say like, ah, this goes to this table, this goes to this table. We've got the IDs of everything that needs to be updated. And theoretically, it should be as fast as you can get. Okay, it feels faster to the client. Oh, man. It feels faster to the client, and no one needs to know that your database isn't actually that fast. All right, so we want to use this for real-time web, right? Real-time game servers. So the nice part about games is that they're already typically designed in a way that we only send user actions over the server. They offer patterns for replay through Redux, so that's ideal. Because I don't know anybody who wants to like build a game that's not replayable if you're building a game that you want lots of people playing. Easy way to manage disconnections and reconnections. Necessary to have a single source of truth. But the cool part for me are actually the business implications that I started thinking about after I started building some pet projects with this, which is real-time collaborative document editing. It's necessary, once again, to have a single source of truth, just like our game engine. Only the user's actions should be sent over the network. We want to keep this light. We want to keep it fast. Ideally, we're batching these updates into periodic saves to reduce the load on our database so that we can scale this thing just by increasing our Redux cluster rather than having to shard our database and have multiple database instances, which are inherently more expensive. All right. This last slide is like some of the weird, cool stuff that I thought about that I haven't implemented, but I know is theoretically possible. So in Redux, everything is a function. But the nice part about JavaScript being a language that supports higher order functions is that we can dynamically generate functions on the fly, which means you can have dynamic reducers. So bear with me for a second as I explain to you that I think Redux would allow you to have an infinitely expanding game world, all while having a relatively finite memory footprint. So if you think about it, if I have a game universe and I'm here in this world and somebody else is here in this world, and we'll never, in any likeliness, on the same screen be able to see each other, I don't want updates for what this person is doing. But does that mean that I need to create a totally separate instance of Redux? No. All I need to do is create a pseudo slice of state that's based on the user's location. You could theoretically even overlap them and say, as we get into this middle territory, I'm sending the updates to both users rather than a user over here and a user over here. Once again, this is theoretical and I haven't built it, but when I do, well, maybe it'll be time for another crazy talk. Another thing that's really fun, remote control of front ends. So imagine if I had come up here and I thought about doing this, but I wanted to build the other thing more. And I thought about having you guys go to your phones and like open something up, and then I would like key through my slides and it'd be like moving on your phone. And I'd be using Redux on both places. But I decided not to do that. But if you wanted to do a remote presentation where you're guiding an entire group through, this would be trivial to set up if you're using Redux on the back end and Redux on the front end. Also in a way that somebody could say, refresh their app and be immediately back on the same page they were when they left off. All right, this one is great. So let's say you are wildly successful beyond your dreams, and you know, your game makes it past the Santa Barbara JavaScript fundraising, and suddenly thousands of players are sending updates to your app every like, I don't know, 10 or 20 milliseconds. Well, guess what? At the time when you're starting to get thousands of messages, thousands of events, at some point it's going to become cheaper to send the game state down rather than broadcast every message. Well, guess what? We still have the ability to do that. All we need to do is set a timer on there and say, hey, if this many actions come in on this within this time period, let's just send the new state down to our users. And we're going to save them some data, we're going to save us some data, and our app is going to be able to scale a lot more smooth. All right, Tim is here, and Tim loves testing. But the nice part about reducers being pure functions is that they are trivially easy to test, because you give them an argument and they should always return the same thing. That being said, you can do some quick TDD for a reducer, and guess what? Oh man, well, you get to share the tests on the front end and the back end. Okay, this is the fun part of the presentation, where you actually do get to go on your phones or on your devices to this particular website. It's game.dallashall.tech if orange is not your color. Type in your name and then click go. This is not what I would consider amazing code, which is why you can't just hit the enter. But we should start seeing some people pop up. Oh, hey guys. Oh yeah. The URL. Hold on. Swipe back to it. Game.dallashall.tech.
I'm facing you. Hey, I'm looking down on you from just above you.
So you can't run into anybody. Now, yeah, not secure. I didn't set up my HTTPS on my server for this. Oh, A and B do nothing. I originally had some plans to implement some features, but my in-laws were in town. So, yeah. Okay, so some of you might notice that it's actually updating on the TV faster than it's updating on your phones. Is that the case for anybody else? Yeah, so I mentioned some stuff about performance. So this is not written using any kind of game engine. This was written using like the fastest I could create a guy moving around on the screen, which is literally just translating a bunch of individual people around. So the most expensive step in this entire app is actually the re-render that React is doing as I'm translating. Yeah, so in terms of things like feeling responsive, yeah, it wouldn't feel any more responsive to you, even if this was running like locally on your phone and not talking to the server.
We have a lot of people now.
Yeah, we got a lot of people happening. Also, like if I disconnect, like if I come here and I say, yeah, I'm done playing, oh, boom, disappear, and I'm gone. So we're cleaning up people as they leave too. Yeah. Now, if you go back, I don't have it maintaining your location, though it could be really trivial to implement, mostly because I didn't want to store anything in local storage like your user ID. So I was just like, well, let you go ahead and do that. So lesson to tell you can't create a very simple game engine using Redux on the back end. You can, and here it is working live in front of you and not crashing, surprisingly, which is great. I really only tested this with like me and my wife sitting on her laptop, begrudgingly saying, okay, do I have to keep moving it back and forth? Yes, and then my son on his tablet, but he's better at pushing like the back and home buttons and not those ones. They weren't fun enough for him. Okay, so I'm gonna move away from this. You guys are welcome to stay on your phone or whatever device you're playing that game on. So here is all I'm doing. This is all I'm sending. Every time you're moving, I am sending. Oh, sorry. This is the state of the app. Sorry, not what I'm sending. The state of the app is just a object of players keyed by their ID, along with their X, Y location, and the direction that they're facing. That is all a player is. All the rendering is handled by the front end. There's no render logic on the back end. All the back end does is say, hey, when you're moving, are you running into something? If you're running into something, I'm just going to eat that action and not broadcast it out to anybody. All right, so the nice part is there's the same actions for moving a player on the front end and the back end. So all I do is I say, oh, I'm going to place a player, and I'm going to send a user and their coordinates. So I told you that right now, I told you guys you shouldn't have to send what is being stored in state, but I did that because it was really simple. What I should have done is just said, hey, move player up and the player ID, and that's all I should ever have to send in order to move a player. The back end should say, hey, should check for collisions, play it against the Redux store, and actually move the player that way. And that would make a lot more sense. So first thing we do, once again, just to reiterate this for the last time, the first thing we do is we pull the state out of Redux once an action goes to the server. We check if that action is valid. There's a separate slice of state that only lives on the server that makes checking for collisions really fast. But I don't need that living on the clients because they're never going to use it. And I do nothing if it's invalid. I just say, oh, thanks for that action. Nobody's going to hear about this. We dispatch the action if it's valid, which means we play it against our store. we create a new state, we save that state in Redux, and at the same time, we broadcast that action back to all the clients. On the client, user presses a button. An action is created, sent via socket connection to the server. The client receives an action from the server. It's just automatically dispatched. I really only wrote one thing, and that was socket.onAction dispatch action. And it just dispatches it, and it's done. The current user is tracked only by the client. So the server doesn't know who the individual people are. They know the IDs of the individual characters, but they don't know that like your device is this thing. Now, that's a security flaw because obviously I could just key hack somebody else's person and start sending up a bunch of coordinates saying, hey, I'm going to make people just jump across the screen. But we could easily change that and say, hey, you're now tied to maybe an IP address or something simple. So performance. Once again, rendering is the slowest part. Yeah, so if it was updating faster on the screen than it was on your phone, that should be pretty normal. Phones are notoriously slower than my computer. And then it's not currently optimistic, but it easily could be with some minor changes. Now, the way our data is stored on the front end and the back end here, it'd be nearly trivial, and we would only run into a few different edge cases where I would update something on the front end, and it would end up with a different state than what's on the back end. And in that case, I would have to handle something like an invalid state. Now, I could easily implement some collision checking on the front end if I wanted to. And then I would avoid most of those things. But there's also the chance that something gets like slightly out of sync, and I'd rather just not do that and just let people play free range. OK. Questions, opinions? Luke.
So apart from the collision detection logic, which you said is just is the rest of your reducer logic the exact same on
Yeah. So apart from the collision detection, the only thing I did was I copied my reducer from the front end and pasted it into my back end. Yes?
Have you done any rate limiting on actions? Because the first thing that any hacker, game hacker would want to do is do something really, really fast before everyone else does it.
Yeah. So I haven't done any rate limiting. I'd probably do that on the server level, not on the Redux level. Yeah. Any other questions? Does anybody think this is like a really terrible idea? Please, somebody raise your hand.
I don't think it's a terrible idea,
Oh.
but one of my questions was, is there anything like flawed with that approach that you're aware of?
Yes. Is there anything flawed with this approach that I'm aware of? I should have made a slide for that. No, this is perfect and solves every use case. No, so somebody pointed out rate limiting, but this is because actions are so simple, you would actually have to add something in there that would identify the individual device in order to prevent cheating in the case of, say, a game server. But also, you're relying on your initial handshake with your server. So like, let's say you're using this in an authenticated environment. You have to make sure that you have a decent handoff between your main application and your socket server connection as you're transferring somebody's data through a live app. Because right now, like this is HTTP, and this is an insecure socket. You could easily just be like Wiresharking this and like getting every action that's being played. Now, that being said, it's totally useless without capturing the initial state. But if you had that, you could replay every change that was made to the document. So, but that's just normal web development security. That's not specific to Redux on the back end. Yeah, in terms of Redis, the larger your state gets, the longer it will take to serialize and pull out. So if you have a finite size of state, so the way I designed this is n size, so it grows 1 unit with every player who is playing. It doesn't grow exponentially. So I think this could scale fairly well to a certain number of players, and at that point I'd probably cap it off, call the world, and spin up a new instance of a world. Here first.
Have you ever considered combining Redux with WebGL? Because I think, especially for game development, that'll be very useful.
For sure. I have thought about that. I didn't do it because, like I said, I'm lazy and I like to make rather the cheap way of doing things for these presentations rather than like diving into them. But yeah, if I wanted this to go faster, I could use Canvas or WebGL, and it would go significantly faster in terms of the rendering step. And then we might start getting to the point where we care about that latency between you and the server in San Francisco.
question. What is that latency?
What is the latency? Okay, so when I was running these tests, and I don't want to expose my DigitalOcean passwords, but I was getting like ridiculously low latency. So the nice part about a WebSocket is your connection's already open, so you lose a lot of overhead. So I was getting 20 millisecond, like on average latency. And for a game, for that to like go, that's round trip. So that's you sending it out, it's processing in Redux and coming back to you, which is just ridiculously fast. Okay speeds for your normal like first person shooter is like the 100 to 200 millisecond range. So I'm well within that. Granted, this is like, that was me, my wife, and my child sometimes pressing on a button. So it's like 3 people connected. And it could potentially get slower, but there are tons of ways we can speed that up. One is to limit the size of the initial state. We could get a faster serializer for our JSON store. There are some pretty cool libraries that will optimize the way you store your data so that it can be serialized to a string faster and stored in Redux and also pulled out faster. But ultimately, like JavaScript will probably be our bottleneck if we don't scale out into n number of instances as well. Other questions? Yeah.
I can see this stemming from a developer perspective. So you want to make this a real game where there's a lot more interaction than just being able to move the person up down the thread.
Yeah.
So you have a lot of duplicated logic on the back-end producers and you do on the front-end producers. Are those always going to be, the same? Like, is it going to get confusing, like what logic is going to go on the front end, what logic is going to go on the back end?
So I don't think it'll be confusing at all. I think that rather than be confusing, it's going to be really simple because you only write it on the front end and you literally copy it to the back end. You're creating a carbon copy. You don't want a different reducer on your back end than you have on your front end, or you end up with a different state. So that's something we just don't want. Now, in terms of it getting larger, I mean, we're going to have to write the logic for like every action that a user does when we're developing a game anyway. You might as well write it in one place, use it twice, once in terms of rendering, once in terms of like figuring out what the game state should be, and the other time in terms of rendering to the client. Yeah. So who's gonna go back and use Redux in their production projects? Wasn't a good enough sell. Yes.
Is there an example of like production app that uses like similar thing as this?
Yes. So Redux is built on event-driven architecture, meaning you dispatch an event, you respond to an event, and something happens. The fact that it uses a pure function is kind of like a novelty, but it's not unique in that sense. So if you think of like any massive scaling architecture, I want to say Java has one. Is it Spring that's mostly event-driven? Any Java people here?
Spring's a massive framework.
Yeah, man.
Java and Swift person here.
Yeah.
Java, JavaScript, Swift, and well, C++.
Yeah.
So I know that Java has a framework that is heavily event-driven and uses a similar idea, but I don't know. I imagine Elixir would get you a little bit closer because it's dealing consistently with functions. But still, if you don't change your idea of like what you send and what you store in the database, you're not going to get close to what you're getting with this. Yes.
So I'm just curious, when I think of Redux actions, it doesn't feel materially different than a Rabbit message.
Mm-hmm.
And so I'm curious if you ever thought that you were sort of parallelizing the same thing that Rabbit does, like trying to build a messaging system. I
haven't used Rabbit, but I mean, yes, it is definitely a copy of some message system somewhere.
Yeah, I think that the reason like Rabbit is one of a bunch of messages. So the pub sub part of it, what Dallas is talking about is the observer pattern, class observer pattern.
Yep.
And so any of these messaging systems, they handle the publish subscribe part of it. The difference is Redux also has a state. So it not only does it respond to those actions, but what it doesn't respond to those actions, play them state. But you could certainly have some sort of a state manager listening on the other end of Rabbit and doing that and then rebroadcasting the state.
Cool. All right, well, that's what I've got. You guys are welcome to come and like pick my brain later. Feel free to reach out on any of the social Twitters or LinkedIn's or even Meetup. And yeah, and I'm more than happy to share with you the repository. It's github.com/DallasHall/ SVJS. Yeah.
That was really cool. I'm picturing that like him implementing all the to-dos and all the coulds, and that being like a kick-ass talk at JSConf next year with 500 people in a room playing this multiplayer game. Yeah, that'd be cool. Right on. So it takes a lot of work and a lot of guts to get up here and give a talk. Let's give Dallas another big round. And you too could be standing up here where this young man is, dazzling us with your JavaScript knowledge next month at Procore Technologies for lightning talks, or for any future event past December. Just let us know, and we'll get you on the calendar. And with that, that's all I got for you guys. See you next month.